United States, Russia, China, France, and the United Kingdom. These are the 5 official nuclear powers on the planet. Besides them, India, Pakistan, Israel, and North Korea can also produce an atomic bomb. But what about Brazil? Are we close to manufacturing a nuclear warhead? And what would be the consequences of that? That's the topic we explain in today's Fronteras program. Before talking about Brazil, we'll take a few steps back to explain how the construction of an atomic bomb works. As you can imagine, it's a very complex process. It all starts with this chemical element here, uranium. Nature provides uranium in large quantities. It is dense and unstable, and that is precisely why it can be used in a nuclear weapon. What makes uranium special is its ability to undergo nuclear fission, a process in which the atom's nucleus splits into smaller parts and releases an enormous amount of energy. But not all uranium is suitable for this. It all depends on the type of isotope. If you didn't skip your chemistry classes, you might remember that isotopes are atoms of the same element with the same number of protons but different amounts of neutrons. Natural uranium has 3 main isotopes, but only one of them, U-235, is useful for making a nuclear bomb, and it represents only 0.7% of all the uranium that nature offers. That's where the enrichment process comes in. Since U-235 is very rare, it needs to be separated from U-238, the most common isotope of natural uranium. The problem is that the two are practically identical from a chemical standpoint, so this separation is extremely difficult. The only difference between them is their mass. U-235 is slightly lighter than U-238. It's this tiny difference that scientists exploit using machines called ultracentrifuges that spin at extremely high speeds to separate the lighter isotope from the heavier one. To generate energy in nuclear power plants, the required enrichment level is actually quite low, between 3 and 5% of U-235. But for a nuclear bomb, it's necessary to reach 90%, the so-called military-grade enrichment. In other words, the difference between lighting up a city and wiping it off the map lies in the concentration of U-235. The atomic bomb dropped on Hiroshima in 1945 used uranium enriched to 80%, which was already a great feat. But if the uranium had been enriched to 90%, the impact would probably have been double. Today, the standard in the United States for military-grade uranium is 93.5%. Now, going back to the question from the very beginning, where does Brazil fit into this story? Well, Brazil developed its own centrifuge technology back in the 80s through the Navy's Technological Center in Sao Paulo and IPEN, the Institute for Energy and Nuclear Research. Today, we have an enrichment plant in Rio de Janeiro which produces uranium enriched up to 5%, enough to supply part of the fuel for the Angra 1 and 2 power plants. But to manufacture a nuclear weapon, much more would be needed, including expanding the enrichment capacity and installing more centrifuges. It's worth adding that the Navy also runs an industrial center in the interior of Sao Paulo, which since the 80s has operated a pilot enrichment module to fuel the reactor of a nuclear submarine. There, the technology already reaches levels of up to 20%. According to estimates, Brazil, with its current structure, could produce material for a nuclear bomb in approximately 1 year, simply by changing the objective of the Rio enrichment plant and refining uranium up to 90%. But the technology, believe it or not, would not be our biggest problem. The main challenge would be to keep everything secret. Brazil is a signatory to the Nuclear Non-Proliferation Treaty, and therefore receives international inspectors who closely monitor the flow of uranium at these facilities. If the Brazilian government decided to develop a nuclear bomb, it would have 2 options: either suspend inspections and officially withdraw from the treaty, or do everything in secret and produce the material in a clandestine facility. Not an easy task. An alternative plan to using highly enriched uranium would be to resort to plutonium-239. This material is not found in nature in large quantities, but rather is produced artificially in nuclear reactors from uranium-238. For this, Brazil would need two things: a specific reactor capable of generating plutonium and a reprocessing plant to extract the material from the irradiated fuel. In the 1970s, the Brazilian army began working in this direction through a study parallel to the official nuclear program. The military studied the construction of a graphite-moderated reactor, fueled with natural uranium. This configuration would allow the production of plutonium beyond the reach of international oversight, but just producing the material is not enough. Advanced physics and engineering laboratories are also needed to design, assemble, and test the bomb. During the secret military program, the Air Force built underground tunnels in Pará for possible nuclear tests. But these shafts were sealed during the democratic opening by the then President Fernando Collor de Mello, as proof of the country's abandonment of its nuclear ambitions. Since then, our constitution has prohibited nuclear activities for non-peaceful purposes. Even so, the choice to develop a bomb would have major geopolitical repercussions. The international community, in general, is against the proliferation of nuclear weapons. Brazil could probably make an atomic bomb, but the central question is, should it be a nuclear power? It's not a small challenge, but giving that up is also a choice. And every choice has a cost. Uranium, centrifuges, secret reactors. Shafts in the middle of the jungle, it seems like science fiction, but it's history and it's Brazilian. Behind the diplomatic speeches and promises of peace, there is a country with uranium reserves, technology, and technical knowledge to cross the line if it decides to do so. In the end, an atomic bomb doesn't start with an explosion, it is born from a choice.